Okay, this is for FRQ number 2. So we have a function f that's defined here. We have a couple of different constants here. A, B, and C are constants. The graph of f has vertical asymptotes at x equals 1, and f has a removable discontinuity at x equals negative 2. Show that a is equal to 2 and b is equal to negative 4. So if this is going to be a removable discontinuity and this is going to be an asymptote, that would mean that if I plug in negative 2 or if I plug in 1, either one, then this should be equal to 0. So I'm going to do both. We're going to plug in 1 and we're going to plug in negative 2 here for x. So let's say that we plug in 1. So we get 2 times by 1 squared plus a plus b. If that makes sense. Does that make sense? I think it does. So, and then we have to set this equal to 0. Yeah, we want to show that by plugging in 1, this will equal 0 because it's an asymptote. And then this just means that we get, we would get a plus b is equal to negative 2. Now we can't do anything with this just yet because we have to plug in negative 2. So separately we're going to plug in negative 2. So we get 2, negative 2 squared plus a times by negative 2 plus b, set that equal to 0. We'll do some math there. We got negative 2 squared, which is going to be 4 times by 2. So that's going to be positive 8. So then we'll have negative 2a plus b is equal to negative 8. And you can see here that we have a system of inequalities, or not inequalities, we have a system of equations. What we could do is solve for a, and then we can substitute that in for a, or vice versa, we could solve for b. So whichever one you guys like. I think I'll solve for b here. So if I solve for b there, I would get b is equal to negative 2 minus a. So I'm going to substitute this right here into the other one. So negative 2a plus, or I'll just say minus 2 minus a is equal to negative 8. Now we can solve for a. And then, so from that spot right there, I could move this 2 over there by adding 2. These are like terms, so that would become negative, so negative 3a, which would be equal to negative 6. When I add 2, I can divide by negative 3, and I would get a is equal to 2. There you go. So a is equal to 2. Now we just have to show for b, but now that I know that a is equal to 2, I can plug that in right here. So b is equal to negative 2 minus 2, so that means b is equal to negative 4. And there we go. So we have b is equal to negative 4, a is equal to 2, and therefore we can show that that's, so this is the value of a, and that's the value of b. We've proved it, okay? All right. Find the value of c and justify your answer. Well, let's go ahead and plug these values in for a and b. So I know that I'm also going to factor this right here. So I'm going to factor out, I'm going to say f of x is equal to x, and then I'm going to have c minus 5x over, and then I'm going to have 2x squared plus 2x minus 4. All right, I'm also going to factor this. The greatest common factor here is 2, so I'm going to pull out a 2. So if x, we have c minus 5x over, pull out a 2, that's going to leave me with x squared plus x minus 2. Now I'm going to factor this right here. So I got x, I got c minus 5x over x plus 2 and x minus 1. That checks out. So then right here. Now we know that f has a vertical asymptote at x equals 1. So this is the asymptote. Now if this is a hole, which is a removable discontinuity, that means that these need to be able to cancel out. So that would mean that x plus 2 has to be equal to c minus 5x. When x is equal to, I want to say -2, but okay. So those need to cancel out. So how, okay. Let me think for a second. We're trying to figure out how these will cancel out. Oh man, I feel like I'm like right there and I'm not seeing the way. So if you guys can see it, that's great. But x plus 2, c minus 5x has to be equal to x plus 2. So in that case, what if we just said we have x plus 2? Let's just take this right here, and let's say that we multiply it by -5. So if I multiply this by -5, I would get -5x minus 10. Which would be this right here. That's how they would cancel out. So would that mean that c is equal to -10? Yeah. That would mean that c is equal to -10. Okay. I think I know another way to. That doesn't feel like a safe way, but let me see if this way would work better. So since I know that this will be a hole whenever this is equal to 0, that's what we're checking for. That would mean that this would also have to be equal to 0. So if I take c minus 5x and set that equal to 0, here we go. Yeah, and then since this will be equal, since this will be a removable discontinuity or a hole at x equals -2, this would also have to follow the same thing. So at x equals -2, so we'd have c minus 5 times by -2 equals to 0. So we'd get c plus 10 is equal to 0. So therefore c has to be equal to -10, and there you go. That's what we would have to do right there. I think that's right. Cool. All right, I think I'm good with that. Let's go to 22. To make f continuous at -2, f of -2 should be defined as what value? So this is where the removable discontinuity is. And so now that we've established what c is, so let's say we take f of x. Well, since we know that it's the hole, we could even just say this. So f of x is equal to, since it's a hole, those will cancel out right there. So we would have x over 2 times by x minus 1. And then from here, we can just plug in -2. So then f of -2 would be equal to -2 over 2 times by -2 minus 1. So this will be equal to -2 over 2 times by -3. So then we're going to get -2 over -6. I feel like I kind of jumped a little too quick right there. I'm backtracking a little bit. I don't feel, we need to plug in C right here. Yeah, I'm going to plug in C. Yep, I need to plug in C. I made a mistake. So we have f of x is equal to x. We're going to plug in C, which makes it negative 10 minus 5x over 2 times by x plus 2 times by x minus 1. That's right. So these can't cancel out until I plug in these values, because those don't cancel out because those aren't the same factors. I have to factor out a negative 5 in order to get those factors to be the same. So I factor out a negative 5, and that will become negative 5x. So if I factor out a negative 5 from both these terms, this becomes positive x. If I factor out a negative 5 from here, that becomes plus 2 over, now we have 2 times by x plus 2 times by x minus 1. Now those can cancel. And then that's going to be equal to negative 5x over 2 times by x minus 1. Now I can plug in negative 2. So f of negative 2 will be equal to negative 5 times by negative 2 over 2 times by negative 2 minus 1. So it's going to be equal to 10 over 2 times by negative 3, which is going to be 10 over negative 6, which is going to be equal to negative 5/3. So that's what it would have to be right there. So f of negative 2 would have to be equal to negative 5/3 for f to be continuous. Be continuous at x equals negative 2. Write an equation for the horizontal asymptote to the graph of f. So that means we need to evaluate the limits at positive and potentially negative. I'm just going to say positive infinity. Whenever it's a rational function, meaning that there's a polynomial on the numerator denominator, it's going to be the same at positive or negative infinity. So if we know that f of x is equal to, let's see, negative 10x minus 5x squared over 2x squared plus 2x minus 4. And if we do the limit as x approaches infinity of f of x, let's go and look at magnitude. So the leading terms are what we want to look at. So it's going to be equal to negative 5x squared over 2x squared. Those are the magnitude, which will, since they have the same magnitude because they're both x squared terms, it's just going to become negative 5 over 2. So negative 5 halves. So horizontal asymptote at y is equal to negative 5 halves. So there you go. That's the equation, and this is the work for it. Okay. All right, and that's question number 2.